Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for December 5th. I wanted to remind you before we get started that we will be having a test over Chapter 6 at the end of this week on Friday. This is a much shorter chapter than Chapter 5 was. So that being said, and then of course we're planning a test on December 20th right before we go on break. Okay. Today we are learning to solve absolute value inequalities, and we must remember that the definition of absolute value, you must get the definition right. If you don't have the definition right, you will always do the problems wrong. Absolute value is the distance from 0 on a number line. Okay, do not make up your own definition. Do not say, well, the absolute value just makes it positive. Do not do that. I know kids that do that. I know at the high school level, I know at the college level, and they always get absolute value problems wrong. Okay, and they don't know why they're getting it wrong. Absolute value is the distance from 0 on a number line, and remember that distances are always positive. Okay, let's say we have a problem that looks like this. 2x minus 4, absolute value of 2x minus 4 is less than 8. Okay. To solve this, this is actually a compound inequality in disguise. We need, first of all, to take what we see without the absolute value. 2x minus 4 is less than 8. Now remember my little trick in class today. I don't read this as a less than. I read that as a less than. And I know ands often look like this. They have two inequalities facing the same direction, and things are sandwiched in between. The problem is I need a number over here. Well, this is real simple. See this 8 over here? I'm going to put a negative 8 there. And when I solve this absolute value inequality, this will give me all the possible numbers for x in this original inequality. All right, this is really simple to do. I know you guys know how to do it. Tell you what, why don't you pause it and go ahead and solve for x on your own. I'll bet you can. When you're done, unpause and my work will appear. If you've unpaused, I'm only assuming that you're ready to see my work. I'm adding 4 to all 3 parts of the inequality. Okay, I'll get negative 4 is less than 2x, which is less than 12. And then, of course, I need to divide by 2. And that will give me the inequality. Negative 2 is less than x, which is less than 6. I can graph that solution on a number line. Of course, I need to show negative 2. I need to show 6. They'll be open circles. And I will test. I'll pick a number that makes both parts true. Say like 0. Negative 2 is less than 0. 0 is less than 6. Yep, that's true. I'm shading in the middle. If I should pick a number outside of the two numbers, say to the left of negative 2 or the right of 6, I will get a false statement. I will not get both parts being true at the same time. Now, what does this tell me? Well, this tells me, one moment, there's my original equation, right? Excuse me, inequality. Okay, there's my original inequality. This graph next to it, the number line graph, I just found out x could be any number between negative 2 and positive 6, and this will be a true statement. Anyone in there. Can't be negative 2. Negative 2 won't give me a true statement. Okay. 2 times negative 2 minus 4 is less than 8. Well, this becomes negative 4 minus 4, absolute value of all that, of course, which becomes the absolute value of negative 8. Now, the absolute value of negative 8 equals 8. But is 8 less than itself? Absolutely not. So you see, negative 2 does not work as a solution. Positive 6 will not work as a solution. But any other number that I choose will work as a solution that's between -2 and +6. You can test that if you're not sure about it. Okay, so let me get rid of this here, and let's look at another example. Let's suppose we had the absolute value of 5x minus 1 is greater than or equal to, oh, I don't know, 7. Okay, this one's a little bit different. It's still a compound inequality like you've been doing on your homework. You need, first of all, to write down what you see without the absolute value. We're going to test for those numbers. Or, remember this, I don't call this a greater than, I call it a great. Or, okay, hold on one second here. Sorry about that, I had to fix a technical snafu, but I think we're good. Remember, I call that a greater than or equal to. So, to get the other side, I'm going to take what's inside the absolute value, 5x minus 1. I'm going to flip my inequality and change it to a -7. This will give me both parts of the solution. The danger in thinking about absolute value just makes something positive is that you will often forget to do the second part. Kids will start to try to solve right through the absolute value. They'll add 1 to each side and then divide by 5. You can't do that. You cannot add through an absolute value. You have to break it down into its two parts and then get x alone independently in both of the parts. Okay? All right, so now I'll come over here and solve this one. 5x be greater than or equal to 8. Divide by 5, divide by 5. X is going to be greater than or equal to 1 3/5. Okay, or I need to come over here. The steps in this case will be to add 1 to each side, just like in the last part. I'll get 5x is less than or equal to -6. I'll divide by 5. X be less than or equal to -1 1/5. Okay, so there is the complete solution. Must have both parts to get full credit, and those of you that will choose to not do both parts, you will lose so many points on the test because you'll only do half the problem. All right, my number line would look like this. Okay, let me see here. I've got a 1 3/5 over here with an open circle. I've got a -1 1/5 over here with an open point. And I've got to see which way's the shade. Let me see here. Okay. Well, this first part here, I need numbers bigger than 1 3/5. Well, I think the numbers bigger would be to the right of 1 3/5. And for this part here, I need numbers smaller than -1 1/5. Well, those numbers would be to the left of -1 1/5. And there is my picture. Remember, I told you in class, I showed you with your hands, that typically, in almost all cases, ands will look something like this. Of course, the circles could be closed. Ors will look something like this. And again, the points could be closed, right? Okay, there you go. That's what's going on. So I'll tell you what, let's see if you can, you don't even have to do the whole problem, but let's see on these 3 examples if you can break them up properly. Let's do the absolute value of 4x minus 7 equals 10. Let's do 5x minus 8 is less than 12. And then let's go with the absolute value of -2x plus 4 is greater than or equal to 9. Again, you don't have to solve the whole problem, Okay, but I want to see if you can break it up into the two parts. Go ahead and pause. When you've broken them up, each problem up into the two parts, you can unpause and check your answers. Okay, if you've unpaused, I can only assume that you're ready to see how the problems get broken up. This is an equals problem. I haven't mentioned this before, but equals problems will be treated just like ORs, except their graphs aren't as elaborate. Yeah, there we go. 4x minus 7 equals negative 10, or 4x minus 7 equals positive 10. And I said those backwards, but it really doesn't matter. All right, number 2, 5x minus 8 is going to be less than 12, and that is going to be greater than negative 12, like that. Now, some of you might be going, why does the inequality flip on the greater thans, but it doesn't on the less thans? Actually, it does. If you look right here, you see the 5x minus 8 is near the small part of the inequality. It's smaller than this number, right? But if you look over here, the 5x minus 8 is larger than the negative 12. So therefore, the inequality has changed direction. It doesn't look like it has. I find it easier just to solve it this way. Okay? All right, let's see here. Number 3. Let's break that down. Negative 2x plus 4 is greater than or equal to 9. Or negative 2x plus 4 is less than or equal to negative 9. And there we go. All right, so there are your 3 setups. I'll tell you what, if you want to pause again, I'll go ahead and solve them, and then you can check your answers, and we'll be done for this evening's lesson. I did it kind of backwards. There's the solution for problem number 3. Okay. Just a minute, I'll show you the solution for problem number 2. Okay, there's my solution for problem number 2 with my graph over here to the right of it. And next I'll have my solution for problem 1. Okay, there's my solution to problem number 1. It works a little disorganized, but I think you can follow it. The steps are in red, and I come up with a solution right here that x equals 4 and 1/4, or x equals negative 3/4, and then I graphed it on the number line. Now, graphing on the number line in that case is no big deal. There's only 2 points. There's no shading involved. All right, this is Mr. Lawrence signing off. Have a good night, everybody.